Hi everyone. In this lecture, we are going to discuss about the topic in Unit 4, Dependent Type Programming Paradigm. Here, you are going to learn what is a dependent type, the logical quantifier for all that exist, and elements of a dependent type like a dependent function and dependent class, relation between data and its computation, and the supporting languages for this dependent type paradigm, IDRIS, ACDA, and Coq, etc. Whenever we are developing a new program, a constant problem arises in that is correctness of the program. So dependent type allows us to write the programs and know they are correct before running them. So you can specify the types that can check the value of your variable at compile time. For example, you can declare a vector that contains the value 1, 2, 3. So val L1 equal to 1 colon 2 colon 3. This creates a variable L1 whose type specifies the vector of data type int. So which implies the vector has the length 3. Similarly, the vector L2 also declared. So using this two vector, if you are applying the arithmetic operation like val L3 equal to L1 we add of L2. So each vector elements in one vector is added with another one vector element. So finally you will get the addition of the two vectors such as L3 equal to 2 colon 4 colon 6 etc. So in the previous example, both the vectors are having same size. So in this, if you are giving the vector of different size, we cannot do the normal arithmetic operation. So at that time, the system will produce the compile time error because you cannot pairwise the addition of the two vectors of a different lengths. So you can expose almost anything with a dependent type, a factorial function which only accepts natural numbers, and login function which does not accept any empty string, and remove last function which only accept non-empty arrays. These are some of the exception cases we can evaluate using dependent type paradigm. In a computer science and logic, a dependent type is a type whose definition depends on the value. It is an overlapping feature of type theory as well as a type system. It is used to encode the quantifiers such as for all and there exist. Dependent types may help reduce the bugs by enabling the programmer to assign the types that further restrain the rest of possible implementations. The languages are XOR, IDRIS, ATS, and ACTA supporting this dependent type programming paradigm. So if you are taking any one programming, we define the function. It has a dependent type if the type of the function results depends on the value of its argument. So second order lambda calculus possesses a function with a dependent type. So always we are saying the dependent type ensuring correctness of a program. So what does it mean to be correct? So depending on the application domain, the correctness may vary. So that should be the first functionally correct. So based on the arithmetic operation we are performing, it is a functionally correct. Second case is a resource safe correctness. Example, which runs within, so the system is running within the memory bounds. No memory leakage happened in that. No accessing of unallocated memory. No deadlock conditions happened in that. Third case is dependent type in terms of a secure, which does not allow access to another user data. Second terminology we have to know in dependent type is a type. So in a programming, types are nothing but means of classifying the values. For example, 94 is an integer type, things is a string. Square within a square bracket, the group of values if you are passing, that is of list data type. In terms of machine, types describe how the bit patterns in memory are to be interpreted. For a compiler or interpreter, types help ensure that how the bit patterns are interpreted consistently when a program runs. For a programmer, types help name and organize the concept. So we are, in general, we are defining the function with a definition. So how to define the function in C and C++, the general code is float, my, div, float, which takes two arguments of a float type A and B. If B equal to 0 means it does not return any value, otherwise it will return the division of the two value. The same functional definition code is replaced in terms of a dependent type code like this: return type, function name with the 2 argument. Third argument is telling the condition of the code. So before evaluating this expression, the system is checking the condition. If the condition is satisfied means then it executes the statement, otherwise it simply ignore the statement. So here, by means of a dependent type programming, auto checking done automatically. So dependent type program using Python example: from typing import union diff return int or string, which takes one argument flag of Boolean type. So if flag, then return a string data, otherwise it return an integer. So based on the Boolean variable flag, the output of the execution will differ. This is also another one example for dependent type of programming. So how to install dependent type programming in Python is, the command is pipe install mypy typing extension. It will install the corresponding packages. After done the installation, you have to import the packages from typing import overload, from typing extension import literal. Then you have to know about the literal concept. Literal type represents the specific value of the specific type. For example, after importing the required package, diff function x literal 1, which implies return of 1. So it will return the x value. So if I am calling function of 1, this statement is correct because it will return the specific value 1 for the specific type literal 1. So if I am calling the same literal of a different function with a different argument, function of 2 means this argument 2 has incompatibility type, okay, whereas we defined only the literal of 1. So this is also another one dependent type example. Then in this dependent type, you have to know about a quantifier. So a predicate becomes a proportion when we assign it as a fixed value. So predicate is nothing but a true for all the possible value in the universal of a disclosure and for some of values in the universal of a disclosure. So such quantification can be done in 2 forms. One is a universal quantifier, another one is a existential quantifier. First take universal quantifier. Universal quantifier is a symbol of a logical representation which specifies that a statement within its range is true for whole elements or whole instances in every element in a particular thing. The universal quantification of the predicate p of x is the proportion. P of x is true for all the values of x in the universal disclosure. The general notation is this one. So for all x, p of x. Example, let the predicate be x must take a discrete mathematics course and another one predicate qx be x is a computer science students. So the universal disclosure for both predicates are p of x and q of x, UNL students. So how this statement is represented in a mathematical form? So express the statement, every computer science student must take a discrete mathematics course. The corresponding mathematical notation is for all x, q of x implies p of x. Now express the statement, everybody must take a discrete mathematics course or be a computer science student. So for this statement, the corresponding mathematical notation is for all x, q of x union p of x. So here everybody must take a discrete course and the student be a computer science student. Another one example to understand this for all universal quantifier. Let's take the statements, all men drink coffee, let a variable x which refers to a cat. So all x can be represented in universe of disclosure as follows: x1 drink coffee and x2 drink coffee, x3 drink milk, etc. up to xn drink milk. So here x1, x2, x3, x4, x5 up to xn are universal disclosures. Then man also universal disclosure variable. So how to represent all men drink coffee? The corresponding mathematical notation is for all x, man of x implies drink x comma coffee. It will be read as there are all x where x is a man who drink coffee. Another one quantifier used in dependent type programming paradigm is existential quantifier. So predicate Px is the proportion, which implies there exists an x in the universal disclosure such that Px is true. So the corresponding mathematical notation is there exists x P of x. So existential quantifiers are type of the quantifier which express that the statement within its scope is true for at least one instance of a timing. It is denoted by the expression there exists. So when it is used with the predicate variable, then it is called as the existential quantifier. So it can also be read as there exists for some x for at least one x. So one example to understand the existential quantifier is some boys are intelligent, x1 is intelligent or x2 is intelligent, x3 is intelligent or up to xn is intelligent. So here the variables are x1, x2, x3 up to xn. Boys is also another one universal disclosure variable. The corresponding shorthand mathematical notation is there exists x, boys of x and intelligent of x. So there are some x where x is a boy who is intelligent. The corresponding mathematical notation is this one. Some of the example to understand these two quantifiers. All bats fly. Now take the question. Here the predicate is fly of bird. And since there are all the birds who fly, so it is represented in the form of a notation for all x birds of x belongs to fly of x. Another one example, every man respects his parent. So in this question, the predicate is respect x comma y, where x is a man and y is a parent. Since there are every man, so we will use for all. It will be represented in the mathematical form for all x, man of x implies respect of x comma parent. Now consider the third statement, some boys play cricket. So in this question, the predicate is play x comma y, where x is a boys and y is the game. So since there are some boys, so we will use there exist, and it is represented in the mathematical form there exist x, boys of x implies play of x comma cricket. These are the some of the examples to understand the dependent type of paradigms. So that's all the topic. It's a very small topic. Any queries in this you can raise. Thank you.